Good morning, students. Till now, we have covered introduction to operating system, definition of different type of definitions of operating system, why we need operating system, goals of operating system, and to achieve these goals, the services or functions provided by the operating system are covered. Till now, we have covered some basic functions of operating systems are process management, memory management, and file management. We had already covered these three managed services provided by the operating system, and now we will discuss storage management, input output system management, security and protection. So let's start with storage management. Under storage management, operating system is responsible for free space management, storage allocation or deallocation for any files, disk scheduling. Now, uh, how the data transfer from hard drive to hardware registers. Let's see. Suppose one any request comes for data retrieve, then the operations are performed in such a way. First, your data is stored in magnetic disk, and this data is transferred to main memory. Firstly, your data transfer from hard drive to main memory, and next from main memory to cache memory, and after that your data transfer from cache memory to hard drive. This schematic diagram shows the migration of data from hard drive to registers. How our data moves from hard drive to register for a storing purpose. Suppose we want to store some data in hard drive, then just the reverse process of this diagram is take place. Like first our data is stored in register, and uh, next after registers our data is moved to cache, then from cache to main memory, and then from main memory to hard drive. In next, IO system management. Operating system is responsible for memory management component that includes buffering, caching and spooling. In next, operating system is responsible for a general device driver interface management. And next, operating system is also responsible for drivers for specific hardware devices. Under the protection and security, firstly we will define protection. Protection is a mechanism for controlling the access of processes or users to the resources defined by computer systems. Protection is a mechanism for controlling the access of processes or users to resources that is defined by the computer system. Or we can say protection can improve the reliability by detecting latent error at the interfaces between different components. Early detections can improve the system performance. Yes, that's true. If if the error is early detected, then we will take appropriate actions to resolve this problem so that the performance of our system is improved. avoid the loss or unauthorized access of data, system security accounts an important role. It is a job of system security to defend a system from external or internal attacks. System security is responsible for defend or detect any external or internal attack. In external attack, attackers try to access our system from outside of our network, and in internal attacks, attackers tries to access our resources or system inside the network. Then after these services, we will discuss evaluation of operating system, how our operating systems are evaluated according to generation of computers. This table shows the four different generations of computers, and during these generations which type of operating systems are used. For first generations, the duration of first generation is 1945 to 55, and the devices used for first generation computers are vacuum tubes, and the type of operating systems is plug boards. For second generations, the duration of second generation is 1955 to 65, and the electronic devices used are transistors, and the type of operating system is batch system. In third generation, the duration of third generation is 1965 to 80, and devices used for third generation is integrated circuit, and the OS operating system used for the third generation is multi-programming operating system. Under the fourth generation, the duration of fourth generation starts from 1980s to till now, and the devices used for fourth generation is large scale integration, and the types of operating system is our personal computer operating system. These are the evolution of operating systems. In next, we will discuss operating system operations. Basically, our operating system operates in dual mode, and these mode are kernel mode and user mode. In kernel mode, operations performed by the kernel, and in user mode, operations commands generated by the users. For differentiating between kernel and user mode, operating system uses a single bit notation. For kernel mode 0 bit is used, and for user mode 1 bit is used. With the help of mode bit, we are able to distinguish between a task executed by OS or executed by users. Task executed by operating system means task executed in kernel mode. For execution of any task by user, firstly user generate a task, create a task, and put a command or generate a interrupt signal. After that, the task is performed by the operating system. It means the user mode transition is converted into kernel mode या फिर system mode. So let's see how ये user mode request is converted to system mode. Transition Firstly, transition from user to kernel mode. Firstly, this interface shows the user process. It creates a process. User process start executing, and after this, a system call is generated, or we can say an interrupt is generated. Then after the interrupt generation, kernel level process is called, or whenever a system call is requested, then the mode is changes from user to kernel. During this, our trap means interrupt mode is equals to 0. After the execution of system calls, again your mode is changes from kernel to system. Here we can say return mode bit equals to 0 means our mode is changes from kernel to user. This shows return from system calls, and this diagram is completely shows how a request performed by any operating system, or how a transition from user to kernel mode takes place. Generally, for user mode, bit 1 is used, and for kernel mode, bit 0 is used. These are the differences for today's class. Firstly, difference between user and kernel mode of operating system, and next one is why protection and security is important for operating system.